Section 2 of Chapter 1 deals with fractions. I know you love them. Here we go. The definition of a fraction is simply a quotient of two numbers, and we recognize them by the way they look, A over B. And hopefully you will remember that the top number we call a numerator, and the bottom number we're going to call a denominator. You should also remember that the numerator deals with the number of pieces that you're talking about. So the number taken. And the denominator has to do with the number in the whole. So the number in the whole. All right. So we need to do, sometimes we need equivalent fractions. And so equivalent fractions, the definition of that is simply fractions which represent the same amount. And so what I've done here is I've shown you, so you know very clearly that this is half of a circle. So this represents 1/2. So you can look at this piece of a circle and you can see, well, it represents the exact same amount, but it's been divided into 2/4. So 1/2 is the same as 2/4. And this one has been divided into 4 pieces. And in the whole, if we were to add all of the pieces up to make a whole, there are 8 in the whole. So that would be 4/8. So 1/2 and 2/4 and 4/8 are all fractions that represent the exact same amount, the same piece of the puzzle, the same piece of the shape. So 1/2 and 2/4 and 4/8 are all equivalent fractions. The way we get those is by multiplying the numerator and the denominator by the same number. If you multiply a fraction on the top and on the bottom by the exact same number, you're multiplying by the amount of just 1. So something like 2/2. 2/2 is the whole circle. So you're just multiplying. If you multiply by 2 over 2, you're simply multiplying by 1. So you're not changing the amount that is represented by the fraction. So what we're going to do when we have a fraction and we want an equivalent fraction with a different denominator, what we're doing is we're simply, we're either chopping that piece of pie, we're either chopping the pie into smaller pieces, or we're putting them together into larger pieces by either multiplying or dividing. So in this case, to get from 12 to 48, we multiplied by 4. So we took that piece of pie that was already divided into 12 pieces and we cut all of those pieces into 4 more pieces so that now the whole pie has 48 pieces. In that case, we've got to cut up the 7 pieces that we already had on our plate. Ooh, that's a lot of pie. So we're going to multiply the 7 times 4. So 28 over 48 is our equivalent fraction. 7/12 equals 28 over 48. Same thing here. If it's negative, this fraction is still going to be negative. So you can either have that negative on the outside of the fraction or as part of your numerator, and it's still the same. So in this case, 42, to get from 42 to 7, what we're doing now is we're dividing those pieces up into, putting them together into larger pieces. So in this case, we divided these 42 pieces up into 6. So 6 pieces that go on each plate. And so now there's only 7 in the whole. So 42 divided by 6 is 7. So we have to do the same thing on the top. Whatever you do on the bottom, you have to do the same on the top. So 30 divided by 6 is 5. So negative 30, 40 halves, 40 seconds equals negative 5/7. And that is, so those are equivalent. Now sometimes we're given 2 fractions and we want them not necessarily to be equivalent, but we want them to have the same denominator. We want to cut those into the same number of pieces. So we're going to use a couple of terms. In this case, least common multiple and least common denominator. You need to know that the least common multiple and the least common denominator actually represent the same sort of number. It's the same kind of thing, except a denominator is actually in a fraction, whereas a least common multiple may or may not be in a fraction itself. A multiple is a number that you get by multiplying a number over and over. So something like the multiples of 2 would be 2 times 2 and 2 times 3 and 2 times 4 and 2 times 5. So just count by twos. 2, 4, 6, 8, 10. So those are the multiples of 2. If we want the multiples of 3, we've got to count by threes. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and on we go. So to find the least common multiple between two numbers, what we'll do is we'll list those multiples, and then we'll look to see where is the first time that those multiples match. So we can look and see, oh, both of those have a multiple of 6. So their least common multiple, the first time that their multiples match, is at 6. So if we want to find the least common denominator, say between 1/2 and 1/3, what we've done is we've found the least common multiple is 6. So we want the 1/2 to have a denominator of 6 and the 1/3 to have a denominator of 6. And now from here, we work this problem exactly the way we just did this. So 2 times 3 gave us 6, so we have to take the numerator times 3. 1 times 3 is 3. And to take 3, to get from 3 to 6, we multiplied by 2. And remember, whatever you do to the bottom, you got to do to the top. So you take the 1 times 2 is 2. So 1/3 is the same as 2/6. So now these two fractions have a common denominator, and that's going to be handy in the next day or two when you start adding fractions and have to have a like denominator. So let's do these. With 5/8 and 1/6, our denominators are 8 and 6. So to get the least common denominator, we need to find the common multiple between 8 and 6. So we're going to take 8. 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, and let's hope that that's far enough. And then we start with 6. 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. Oh, I see a match, so I can stop. So our common denominator is 24, our least common denominator is 24, and I didn't give myself enough room here, did I? So we're going to make the 5/8 equal to something over 24 and 1/6 equal to something over 24. 8 times 3 was 24, so we're going to take the 5 times 3 is 15. So 15 24ths is our equivalent fraction to 5/8. And 6 times 4 is 24, so you have to do the same thing on the top. 1 times 4 is 4. So 4 24ths is our common our equivalent fraction, so that we have common denominators. What I want you to do now is pause the recording and try to find the equivalent fractions with common denominators for 2/3 and 5/9, and then unpause and come back and see if you got the same thing I did. So now I'm going to go on, and for thirds, I've got 3. 3 times 2 is 6. 3 times 3 is 9, and actually I can recognize, oh, wait a minute. 9 is my denominator, so I don't even have to get the multiples of 9. So 5/9 can stay 5/9 in this case, and the 2/3 is going to equal something over 9. I multiplied by 3. 3 times 3 was 9, so whatever I multiplied on the bottom, I got to multiply the same thing on the top. 2 times 3 was 6. So now 6/9 and 5/9, you see, have common denominators. And that's going to come in handy in a section or two later. All right, now what is next? Once we have common denominators, oh, and your book has some sections called Your Turn. So for finding equivalent fractions like this type on page 11, look for the Your Turn and do some of those examples, and they have the answers right there in your book. And also for this type of problem, look on, I didn't write down what page, oh I did, page 12. Look on page 12 for some more problems that you can work, and then make sure you get the correct answer. Because now we're going to move on to something else. We're going to talk about prime numbers. And go ahead and start putting some of that in your notes while I erase the board. Prime numbers, you may or may not have already studied. Prime numbers are natural numbers that have exactly two factors, itself and 1. So a prime number is a number like 2 because it can only, in order to get the number 2, the numbers that you can multiply together to get 2 are just 2 times 1. Let's see, 5, you can only multiply together 1 times 5 to get 5. But 10, you'd multiply together 2 times 5. So that's not a prime number. In that case, that's a composite number because that's a natural number with more than 2 factors. A factor is a number that you multiply together to get an answer. So factors are multiplied together to get multiples that we just talked about. So go back through and you may have to listen to that a couple of times. So factors are multiplied together to get multiplies. Factors are the parts, multiples are the answers. Okay, so something you need to know about prime numbers just as an aside, just to be sure that you don't make this error. 0 is not prime, and the number 1 is not prime. All right, so 0 is not prime because it's not a natural number. Natural numbers start with 1, and they're the counting numbers. So 0 is not prime because it's not a natural number. 1 is not prime because it doesn't have 2 factors. It just itself is 1, so it just has 1 factor. So 1 is not prime. Neither of them are composite either because, once again, 0 is not a natural number and 1 does not have more than 2 factors. So 0 and 1 are left out. They're not prime or composite. What we're going to do with those prime numbers, I don't know if you can see that under my, we want the prime factorization. The prime factorization is going to be handy for a lot of different things we do with numbers in algebra. The prime numbers that multiply together to make up a number are that prime factorization, and we're going to find those by using a factor tree. And the example that your book gives is a big one to start with, so let's just do it. We can do big ones. The number 360, if we want to know, well, what numbers did we multiply together to get 360? We're going to use a tree to say, well, what times what is 360? Well, I can see because there has a 0 at the end, 10 times 36 is 360. So now, are these prime? Well, no. 10 can be broken down into 2 times 5. And 36 can be broken down into, let's say, 4 times 9. There are a couple of different ways that 36 can be broken down into. And so however you work that is fine. If you said, oh, that's 6 times 6, you do it your way and we'll end up with the same answer. All right, I'll show you. 4 breaks down further into 2 times 2. 9 breaks down further into 3 times 3. And 2 and 5 are both prime. You can't multiply anything together to get those. So your prime factorization are these numbers, and we usually put them in order from smallest to largest just so that we can read it easier. So your prime factorization is 2 times 2 times 2, 1, 2, 3 2s, times 3 times 3 times 5. And to shorten that up, we can say 2 to the 3rd power because there's 3 of them, times 3 squared because there's 2 of them, times 5. And that is your prime factorization of 360. On page 14, you'll see more of those. Do a couple more and see if you get those answers right, and then come back. And let's simplify fractions to lowest terms. Lowest terms of a fraction. Simplifying a fraction to lowest terms simply means that the numerator and denominator don't have any factors in common. So no common factors. No common factors between numerator and denominator. Numerator and denominator. All right? So if there's no common factors between the numerator and the denominator, then you have a fraction in lowest terms. The way you're going to do this, let's do this one and do this one. Woo! Once again, your book just gives you big numbers, and that's okay. We can deal with them. So 28 over 70, if we want to find the lowest, put that in the lowest terms, what we need to do is we need to find everything in common between 28 and 70. Here's a quick, easy way to do it. What you're going to do is you're going to use your factor tree to find all the prime factors of each of these numbers. So 28 is 4 times 7, and 4 is 2 times 2, and 7 is prime. So 28 is 2 times 2 times 7. 70 is 7 times 10. 7 is prime, and 10 is 2 times 5. So your prime factors of 70 are 2 times 5 times 7. Now, if you've multiplied something on the top and the bottom, if you've got multiples, you can reduce on the top and the bottom if they match. So if you've multiplied 2 times 2 times 7 and you've multiplied 2 times 5 times 7, then if they match, you can simply reduce them. And what you've done by doing that is you've divided both the top and the bottom by 2. So you don't have to actually go through that process. Just look, oh, 7 and 7 match, so just cancel them out. So your reduced fraction is just 2/5, and you're done. Haha, pretty easy sneezy. Let's try 156 and 210. Go ahead and try it on your own, and then come back and watch and make sure you got it correct. 156, 210. Did you pause it? Are you back with me now? All right, here we go. 156 divides down into, let's see, we can go 2 times 78. And then 78 is divisible by 2 also. What is that? 3 and 3 is 6 is 18, 9. 39, and 39 is 3 times 13. Whew, weird numbers. That's okay. 21 times 10. 21 is 3 times 7. 10 is 2 times 5, and those are all prime. So let's put them down here. 2 times 2 times 3 times 13 on the top. And on the bottom, we have 2 times 3 times 5 times 7. And if you don't have them exactly in numerical order, that's okay too. It's going to work fine. So 2's match, reduce them. 3's match, reduce them even if they're not exactly on top of each other. If they're anywhere in that line of multiples, that is fine. Line of factors, excuse me. So none of the others match. So now to get your final answer, you're going to multiply those back together to get your final answer. So 2 times 13 is 26. And 5 times 7 is 35. So your reduced fraction is 26/35, and you're done. The last problem that we have, of course, is a word problem. You knew you wouldn't get away without doing a word problem. You'll find it on page 15, so don't worry about writing all of this into your notes. A newspaper reports that over the last year, 160 households per 1,000 were victims of crime. Write a fraction in simplest form representing the fraction of households that were victims of crime. So all we're going to do here is figure out, we're going to look to see how many households were involved. It's 160. It's 160 out of how many in the whole? The whole is the 1,000. So our fraction is simply going to be 160 over 1,000. And then all we have to do is reduce it down to its simplest form. I want to show you a shortcut. When you have zeros at the end, you don't even have to put you can reduce it a little bit first, because if there's a 0 at the end of a number, then you can multiply you can divide it by 10. And so both of these have a 0 at the end, so we can divide both by 10 simply by taking off a 0. So you can do that, and that'll make your problem even simpler if both your numerator and your denominator have a 0 at the end. So we need to reduce, or we need to do a factor tree for 16. 16 is what? 4 times 4, and 4 is 2 times 2, and 2 times 2. 100 is 10 times 10, and 10 is 2 times 5, and 2 times 5. And so bring up for 16, we have 1, 2, 3, 4 2's. And for 100, we have 2 2's, oops, and 2 5's. There it is. So now our 2's match. We can reduce by these 2's. 2 and 5 doesn't match, so simply multiply through. 2 times 2 is 4. 5 times 5 is 25. So 4/25 is your reduced fraction. So 4 out of 25 households were victims of crime. I hope you weren't one of them. All right. I think you've got lots of parts and pieces, and I think you've got all the information you need to do very well on your assignment. I will see you soon.